Hi all, let's start with the next video of PCIe DL layer. In previous video, we discussed with ACK protocols. We'll see in this video one suitable example what for ACK protocols. Let's take a one scenario where let us assume as a you are sending as a 5 TLPs. Assume as a let us assume as a take 10 TLPs. You are sending from your transmitter to the receiver side. You have a RC, you have a AP, you are sending the information from your transmitter to receiver side with a 20 LPs. Let us assume you have a one DL layer, you have a another side, we have a one more another DL layer through communication happen with links. In DL, before sending it to the packets, what happen? You will store the packets retry buffer. That retry buffer assume as a 1, 2, 3, 4, 5, 6, 7, 8. Assume 19 also present. So whenever you are sending data from your this DL layer to another DL layer, it will say it will add as a sequence number and LCRC. That packet will send to this link. Let us assume you are sending packets from your transmitter to receiver. One actually from your transmitter to receiver side, whenever you sending data from your transmitter to receiver side, you will get as a acknowledgement from receiver to transmitter side. So this will happen this much time, its time will be present. Like you are sending and whenever you are sending packet from your transmitter to receiver side, I should get the response within two, let us assume 2 nanoseconds. Within a 2 nanoseconds I have to get the response. That DL RTL design will design with specifications such write the code such a way that whenever data I send from your DL to another side receiver side, I have to get the response within a 2 nanoseconds. Let us assume. So if you whenever let us assume you send a packet with one sequence number is one, you will get as a response with 2 nanoseconds. Within 2 nanoseconds, that will be the correct packet. So what happened, whether it is whether you will get as a ACK or NAC, if you get within a 2 nanosecond, then only it will calculate. Otherwise that DL will layer will send again. That is the first step. This is a time time present is there from one layer to another layer, from transmitter to receiver side, one packet to another packet. Whatever data you are sent from transmitter to receiver side, you should get the response from receiver to transmitter side with a specific time. So when this is the place transmitter will send the packet, right? So within a 2 nanoseconds, you have to get the response from receiver to transmitter side. If you won't get a response, whether it is ACK or not, again it will send the packet. One number, sequence number, again it will send. That is the first step. One more will be the, let us assume you are sending the packet one by one, 1 2 3 4 5 6 like that. Assume where you got a ACK with sequence number as a 4. Assume. So what is the meaning of that one? This scenario, up to 4 is the correct packets. Let us assume you are sending sequentially 1 2 3 4 like that. uh, Once you receive DL layer, it will receive the packet. What happen here, timer will start. This we call as a watchdog timer. What happen, it will start once you receive the packet. What happen, this watchdog timer will start. So once watchdog timer is timeout, what happen, you will get the information whether it is ACK or not. So in this time only, assume as you receive as 4 packets at a time. So what happen, that fourth packet you will get as a ACK or NAC, you will get as a that information from receiver to transmitter side. Let us assume I am sending packets from 1 to 10. In that I got a fourth packet as a ACK. So that information we clear to say that up to fourth packet received as a proper packets from transmitter to receiver side. So again, what happened, from fifth packet it will generate send to from your this DL layer to this DL layer. So up to fourth it will remove from the buffer, replay buffer. So that is the thing will happen. Let us assume you got as a again you are sending the packets from 4 to 10. you got a sequence number 7 with a NAC. So what happened? Seventh number you got received from your receiver to transmitter side with a with a NAC response. So what happened? Up to seventh, it will be the assume as a this receive transmitter DL layer up to seventh as a correct packets. The up to seventh as a received as a correct packets. Remaining packet I have to send. So what happened? Maybe eighth packet or eighth packet. It should be the gotten error, the maybe LCRC or sequence number, some link also we have a maybe one bit if you data it will change, LCRC will be changed, right? So maybe eighth packet got error, so it will send as a seventh sequence number as a with NAC. So what happened? Seventh up to DL layer transmitter will understand like up to seventh it's received as a proper packets. I have to send as a eighth packet with the that is sequence number. So eighth packet again it will send. Initially it's sent, yeah, eighth packet also got an error eighth packet. So eighth seventh packet it's you got an with a NAC response. So it will send again eighth packet with a sequence number from your DL transmitter to receiver side EP side. So again it will try. This is will happen. This is retrying, right? Initially you sent the eighth packet, you got a NAC. May due to issue you can again you are trying with the retry buffer, that again you tried from your transmitter to receiver side. So you may maybe DL will expect like maybe this time we'll get as a ACK. Ex- Expectation will be ACK. Due to some issue again I got an error with an NAC only. So again it will send. Again it will send up to 4 times it will retry. It's retrying, right? From transmitter to receiver to get the acknowledgement. If you get within a 4 times, if you get as a ACK, that is sequence number 8, this we called as a data is whatever data sending from your transmitter to receiver say receiver got received that correct data. If not, it will happen a retraining. A maybe link level we have a issue. So we have to do as a link training. That DL layer will tell to file layer, please go with forcefully it will retrain the link again. So in this way will happen. If you get a sequence number, assume as a sequence number 8 also received as a ACK, so again it will send as a 9 and 10 packets. So in this way uh, sequentially you can able to send the data from your DL layer to resource side of DL layer. So all the information getting from the receiver to transmitter side using DLLPs. This is a packets or TLPs. TLPs. That information getting from the DLL receiver DLL to transmitter DLLs, that will information coming from the DLLPs. So we have a main two packets, that is the TLPs and DLLPs. This DL layer will take care all the packets like TL up DLLP. Based on DLLP, what is the buffer space using a flow control mechanism, what is the buffer space is present, how many packets I can able to send from your transmitter to receiver. So this is the way data transmission happen with a suitable example. That we one more point is a rollover. Rollover. Rollover means like you are trying with 4 times, right? You are getting as a 4 times NAC, 4 time NAC. So this we call as a rollover. That rollover is reaching to 00 01 10 rollover. That number is a for 2 bits, so 4 combination. Once receiving as a 1 1 to again it will go with 00, right? We have to do initialization. So what happened? This we call as a rollover. This is the concept we called as a rollover. So in this video, I took as a one simple example for that how we act knock related. The main point here is was you won't get a ACK or NAC for every TLP. That is the main point here. You may be get, you may not be get. It's based on the situation. You may be get, you may not be get. That is I want to convey in this video. If you have any question, please let me know. Thank you.